So we need to look at the graphs of tangent, cotangent, secant, and cosecant. We're not going to spend a great deal of time with these because they are not nearly as useful as sine and cosine. Sine and cosine, you see uses for them in all kinds of things. Tangent, cotangent, secant, cosecant, those are not ones that are going to be as useful as far as like modeling real world behavior. So, but we do have a general idea of what they look like. So the first one that you see here is tangent. It's a little smaller. So to remind ourselves, tangent is sine of theta over cosine of theta. So if cosine of theta equals 0, what do we know about tangent? If cosine is 0, and it's in the bottom, then tangent is going to be undefined. And on the graph, that's going to be a vertical asymptote. So you'll notice that you have vertical asymptotes here at pi over 2, 3 pi over 2, negative pi over 2, and negative 3 pi over 2. So those vertical asymptotes, I'm really starting from the end here, I guess. Those vertical asymptotes would keep repeating over and over. So it'd be pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2. So if we list those, I'm just going to list it like this. Pi over 2, 3 pi over 2, 5 pi over 2, dot, dot, dot. They'd keep on forever. I guess I should probably start it with a dot, dot, dot there, because in either direction, positive or negative. And these are all the places where cosine is 0 on the unit circle. So if you think about that unit circle, cosine is your x coordinate. So you got 0, 1 here, and 0, negative 1 here. So right here at pi over 2 and 3 pi over 2, those are the two places that we're going to see. We're going to see vertical asymptotes for tangent. What is the period for tangent? How long does it have to go before it repeats itself? Just pi for this one. Because if we start right here at 0, we got this piece of the graph, we got asymptote, then we got this negative piece of the graph, and then it just starts doing the same thing over again, right? Or we could think of like from here to here, from negative pi over 2 to positive pi over 2, that is just pi there. Okay, so the period, and this is the biggest difference and the biggest thing you need to know for tangent. The period for tangent is just going to be pi. Yes, well, the starting place for tangent is your period is going to be pi. So much like sine and cosine, we can have adjustments to that. So we'll see here in a minute that if we have 2 times x, we can change the period of tangent. But just tangent itself is going to have a period of pi. All right, so our x-intercepts here, those are going to occur right here. We can see. And what's happening here, it's all increments of pi. So I'm just going to list it like this, pi, 2 pi, 3 pi, dot, dot, dot. And our y-intercept is at 0, 0 for tangent. So you should be able to identify tangent for me. On a graph. Questions about anything here? The only tricky thing about identifying tangent is cotangent looks so similar. So you can see there are some differences here. What is the period for this graph, though? The difference is not the period of the graph. The period is still just pi for this. The x-intercepts for this one are going to be at, right here, this would be pi over 2. This would be 2 pi, 3 pi over 2. So it's pi over 2, 3 pi over 2. It's going to keep on going, 5 pi over 2, dot, dot. What's our y-intercept? It is a trick question because there is not one, because you have a vertical asymptote right there at 0, so it's never actually going to touch that y-axis, so you have none. And then our asymptotes here, we can see are at 0, pi, we would have another one over here at 2 pi, so 0, pi, 2 pi, dot, dot, dot. Think about the same thing. Cotangent of theta is cosine of theta over sine of theta. So if sine of theta equals 0, cotangent of theta is undefined. Which means you'll have a vertical asymptote at that point. So if you think about that unit circle, sine is your y-coordinate. It's going to have it's going to have a value of 0 at 0 and pi, 2 pi, 3 pi, 4 pi, and so on. So that unit circle relates back to all of this, even with those functions that aren't on the unit circle. The biggest difference in cotangent is that your little segments here are decreasing. And then the second biggest I would say is that it's slid over. Your asymptotes are in different places. You have to be really careful. I'm not going to give you a lot of graphs of tangent or cotangent other than probably just identifying the basic graph. But if we put a negative in front of tangent, it's going to flip it upside down and make it look just like cotangent, except for the asymptotes are not in the same place. So they can look very similar there. All right, secant is really a crazy sort of graph. But secant, and we're going to go over these even more here soon, but secant is going to equal 1 over cosine. So that's something we use with those unit circle values that equals 1 over cosine. So much like we just did for the last problem, you can notice that if cosine equals 0, you are going to have a vertical asymptote. So that's going to occur at pi over 2, 3 pi over 2, 5 pi over 2, dot, dot, dot. All the places where cosine is 0. The period for secant is 2 pi because although like from here to here it's just an increment of pi, this negative portion over here also has to be added. So the period for secant is 2 pi, which makes sense. It's completely dependent on cosine, which also has a period of pi. Your y-intercept here is going to be 0, 1. We're going to leave off the maximums and minimums. We're not going to worry about that for right now. But what I do want to show you right here is if I graph cosine, I want you to watch what happens. If I graph cosine at 1, or at 0, cosine is at a maximum point right there, and it has a value of 1. And then you would go to the midline, minimum, midline, maximum. Same thing over this way. So continue that pattern. So if you look at what happens, secant and cosine really kind of just line right up with each other. Every time cosine hits that x-axis, you have a vertical asymptote. That's because cosine equals 0 at that point. And then every time you have a maximum of your cosine function, you have a minimum of your secant function, which makes sense because you're doing 1 over that value. There. Okay, let's look at the next. Cosecant also has a period of 2 pi. It does not have a y-intercept. And cosecant is going to equal 1 over sine of theta. So if sine equals 0, that's where we're going to see that we've got those vertical asymptotes, like we see here. And so that happens at 0, pi, 2 pi, 3 pi, and so on. Maximum minimums I'm not going to worry about right now. We're trying to move through this. So, yes. It's just because the y-intercept is just the place that it crosses the y-axis. So because you don't have a vertical asymptote at the y-axis, you are going to actually cross it. So it's just that the coordinates of that point. It's only whenever you have the vertical asymptote is at the y-axis that you're going to end up with that, not having that y-intercept. And for this one, we could also graph sine. So it would look like this. And you can see it does the same thing that cosine did with secant. It kind of lines right up there in between. So, one of the big things that you're going to be asked is to find the period for these functions. So, here is the big thing. For sine, cosine, secant, or cosecant, period, is going to be 2 pi over b. But for tangent or cotangent, your period is just going to equal pi over b. So for secant and cosecant, we don't do anything differently than we did for sine and cosine. But for tangent and cotangent, because the basic period for tangent is only pi instead of being 2 pi, we have to do pi divided by the b value. So whenever I am looking at number 1, I've got tangent. Right here is my variable. I've got my x right here. I do not have a number in front of that x, so my period for this would just be pi. For number 2, I'm at cosecant. Cosecant's the same as sine and cosine. I'm going to do 2 pi divided by the b value, which is the number in front of my x here, so 2 pi over 2. I will get a period of pi as well for number 2. Now this can be a little tricky whenever we see this, x over 2. So if I have negative 5 secant, let me write it like this, x over 2 plus 5. I need the number in front of the x, but there's no number in front of the x. I'm dividing a number by x. How else could I write this here? 1/2 times x is the same as x over 2. So that number in front of your x, your b value, is 1/2. So you would do, this is secant, so we still use 2 pi. And we would divide that by 1/2. And dividing fractions is easy as pi. We flip the second and multiply, so we'll get 4 pi for that. So on number 4, when I see cotangent of x over 5, I want to think of that as 1/5 x. So I would do, because this is cotangent, I just do pi divided by 1/5. And dividing fractions is easy as pi. Flip the second and multiply. So we'll get 5 pi. And for our last one here, we're going to use pi. We will divide it by pi, which will just give us a period of 1 for that one. All right, let's see. So I had a few more here. I'm going to skip to number 8. We're going to do it and we'll have to be done. So basically everything is going to work like it works with sine and cosine, except for tangent starts with that period of pi. So if I want to do number 8, it says write the equation of a tangent function that has a period of 4 pi and has been shifted down 5 units. So y would equal, I'm generally not going to give you amplitude on tangent because there's not like an amplitude that's easily quantifiable. It can be stretched out, but I'm not going to give that to you because it's just hard to do. So I would do tangent of bx, no plus c, because I don't need a plus c for this because it's not shifted left or right. And it's going to be shifted down 5 units, so it's going to have a minus 5 here. So I would just do pi divided by b equals 4 pi. Right, so instead of doing 2 pi divided by b like we would do for sine or cosine, we would do pi divided by b equals 4 pi. We would multiply both sides by b. So we get pi equals 4 pi b and divide by 4 pi. The pi's will cancel here and we'll get 1/4 for our b. So my equation would be y equals tangent of 1/4 x minus 5. So although it is slightly different, it's basically the same as what we have done before. Your assignment for tonight, I'm pretty sure is on Desmos Classroom. Let me see. There we go. Yes, and it is going to be the assignment that says all trig functions. I think it's a matching activity. So there's a link here, or you can just sign into Desmos student.desmos.com and it'll be there. So that'll be your assignment for tonight. Okay, that'll be fine. No, I'm not going to take those up.